Hi there, the purpose of this video is to demonstrate junction diode action and Zener diode action in a DC power supply. What we've got here is a bridge rectifier, 4 diodes in a ring. What we're doing with this meter is we're just checking that each of those diodes is working. So we're testing this particular diode here with the voltmeter, sends out a voltmeter, gets the on voltage of that diode to be 0.54 volts. That's on. If we do another diode, let's do this one. We're going from here to here. Let's just check. Yeah, 0.54. So what happens if we swap the leads round? What should the diode do? Should it conduct? No, we don't get any on voltage because we've now got it in reverse bias. So a diode, forward bias, it conducts as a one-way resistor. Reverse bias, there's no conduction. So what's the purpose of 4 diodes in a ring? We'll just move this over. 4 diodes in a ring. We put that in from AC to DC. What we've got, 4 diodes in a ring, bridge rectifier, 4 junction diodes. At any point in time, one pair of diodes will be conducting and the other pair will be off, so that we convert the 20 volts peak to peak 50 Hz AC signal going in here to DC here. The current only goes one direction through this 10 ohm diode which is in there to limit the current through the output circuit. So this side is AC, 20 volts peak to peak 50 Hz. This side is DC. We can see we've got a DC voltage coming out, 9.36. We've got 10 volts peak to peak going in. Through the rectifier we get DC out and we get 9.36 volts out when there is no load on the output. What we've got in here at the moment is 10 nanofarad capacitor in there. We'll take that out. We've also got 150 in there. So what we see there is the ripple coming out because it's not fully smooth, so you actually see the ripple between the peaks of the DC coming out, but the current is only going one way. So if we put a 10 nanofarad capacitor in, we put that in, it does reduce the ripple a little bit with 10 nanofarads, although it's still not ideal DC. What if we put in a much bigger capacitor to store the charge between the peaks, 150 micros, and then we get pretty smooth DC out and we get 9.35. We've got 0 current flowing through the output DC circuit at the moment because we don't have a load connected. So what happens if we put a load resistor in? We'll put a load resistor in the output. We've got 33k there. Do we get much current flowing? We get 0.27 milliamps flowing at the moment, and the voltage goes down quite a bit because there's no voltage regulation. What if we remove that resistor? We put in, say, 1k load resistor. We now get much more current flow, and we now get 6 milliamps. We've got 6.43 volts across here, 1k resistor, 6.43 divided by 1k is going to give us 6.4 milliamps as shown on that meter. So at the moment we've got an unregulated output. So how do we regulate the DC voltage coming out? So what we're going to do is we're going to put a Zener diode in the circuit. Zener diodes are designed to work in reverse mode. So we're going to put the diode in the circuit that way and we're going to see what happens. Before we do that, we're going to take the load out and we're going to put the Zener diode in reverse mode. If you put it in forward bias mode, it just works as a normal diode. So what we've got now is the voltage is now clamped 4.7 volts to the voltage that's stamped on the manufactured Zener, which is 4.7 volts. And at the moment we've got no load coming out, but we do have current going through the DC circuit, going through this 10 ohms, going along here and down through the Zener. So it's regulating the output, and we can see we've got about 30 milliamps going through it at the moment. What happens if we put a load resistor in? We've got 33k again, put a load resistor in, doesn't affect the output, so there is voltage regulation going on, although obviously 33k it's not drawing much current. If we put a lower value of resistor, load resistor, let's see what happens. We put a 1k in there and the voltage goes down from 4.7 to 4.6. Current changes a little bit. So what the Zener diode is doing is provide voltage regulation. So as a summary, 4 junction diodes in a ring, you're going from AC to DC. Current is only flowing in one direction through the 10 ohm resistor. Capacitor is in there to smooth the output. So you need a capacitor to smooth what's coming out. And the Zener is there to clamp the voltage to 4.7 volts to provide voltage regulation, stable output voltage for different loads. So what we're demonstrating here is a basic DC power supply, 5 volt DC supply. Ideally that Zener would be up to 5.6. We only have 4.7 in the kit. So what we're demonstrating here is a basic DC supply that, for example, could feed 5 volts TTL logic circuits, transistor logic circuits, and it shows the action of junction diode and Zener diode. Thank you for watching.